In this lesson, we're going to multiply polynomials. And the first thing we're going to look at is multiplying monomials. And just a little note here, the properties of exponents can be used to simplify many algebraic expressions, including multiplying monomials. And to multiply monomials, we will use the associative and commutative properties and regroup. And this is a period. And we will group coefficients in like bases. So for example, if you look at number 1, and let's suppose we had this for number 1, we have negative 3x to the 4th times 2x to the 5th. All right, so I'm going to, according to our note here, we're going to regroup. I'm going to put all the coefficients together, and then I'm going to put all the variables, the like bases, together. So in this case, I can write this as, and notice this is all multiplication, negative 3 times x to the 4th times 2 times x to the 5th. So I'm going to put all the coefficients together, so negative 3 times 2, and I'm going to put all the variable terms together, the like terms, x to the 4th times x to the 5th. All right, so I use the associative and commutative property. Okay, so in the first parentheses, negative 3 times 2 is negative 6. And in the second one, remember the product rule. So when I multiply like bases, I add exponents. So I get 4 plus 5 is 9. So this is x to the 9th. So I get this product. So these two monomials being multiplied together is negative 6x to the 9th. Okay, and notice that at some point you'll be able to look at this. In your mind you're doing this, but you'll be able to think, all right, we multiply the coefficients together, then I multiply the like bases, the variable terms is like bases, so x to the 4th times x to the 5th is x to the 9th. All right, so remember when you multiply like bases, you add those exponents. Okay, and so number 2, let's suppose that in number 2 we had this example. We had negative 8 a to the second power b to the 4th times negative 2 a b to the second power times 3 a b. So let's suppose we had that. So notice in this case I'm multiplying in parentheses. I have 3 sets of parentheses. So I have this monomial times this monomial times this monomial. All right, so I'm going to regroup. I'm going to put all the coefficients together, all the like bases together. And notice I have variables a and variables b. Okay, so I'm going to say negative 8 times this coefficient, which is negative 2, and then this monomial, my coefficient is 3, times, all right, let's put the variables a together. So I have a squared times, in this case I have a, times, and over here I have a as well. And then the b's, I have b to the 4th times b squared times b. All right, and so now I'm going to use the properties that we've learned in previous lessons. So first of all, I'm going to just multiply these coefficients out. So negative 8 times a negative 2 is 16, and then 16 times 3 is 48. So I get 48. A squared times a times a, remember that's implied to be a 1 here in both cases. When you multiply like bases, you add exponents. 2 plus 1 is 4. And then over here, we have b to the 4th, b squared b. So when you multiply like bases, you add exponents. 4 plus 2 plus 1 is 7. So I get b to the 7th. So that's the answer there. Okay? And so that's what we mean by multiplying monomials. So we multiply monomials. It's pretty easy. You're just going to regroup to where you can think of this as putting all the coefficients together and then putting all like bases together. Okay, so that's that first objective, which is to multiply monomials. All right, we're going to look at another objective. Okay, so in objective B, we're going to multiply monomials by polynomials. So remember in objective A, we were multiplying monomials. In this one, we're going to multiply monomials by polynomials. And in this case, you're going to notice that we're going to be using the distributive property. So let's remind ourselves what the distributive property says. So if I have, let's say a times b plus c. So if I have two or more terms that's being multiplied by, let's say, a, I can use a distributive property, which means that each of those terms has to be multiplied by a, because this is a product right here. So this becomes a times b plus a times c. So whenever you're multiplying a polynomial by a monomial, every term in that polynomial has to be multiplied by that monomial. All right, so let's just look at some examples. So examples in the directions will say multiply. All right, so let's go ahead and multiply. So number one, we have, let's say 3x times 2x minus 5. All right, so I have 3x times 2x minus 5. So I have this polynomial that's being multiplied by this monomial. So to multiply this out, since this is a monomial, I can use a distributive property. So I'm going to multiply every term in here, in this parentheses, by this 3x. All right, so sometimes it helps if you use arrows to indicate that every term in here has to be multiplied by 3x. So I get 3x times 2x, so 3x times 2x, minus, and then 3x times 5. 3x times 5. All right, and now all you do is simplify. So 3 times 2 is 6, and then x times x using the product rule. So x times x, when you multiply like bases, you add exponents. X to the first times x to the first is x squared, minus, and then 3 times 5 is 15, so you get 15x, and there's your answer. Okay, so multiplying a polynomial by monomial is all you're doing is just using the distributive property, and then simplifying as much as you can using the properties that you've learned. Okay, so number two, let's suppose number two we have negative 6y squared times negative 8y cubed plus 3y, and then let's say minus 1/3. Okay? All right, so we have this polynomial that's being multiplied by this monomial. So I'm going to use the distributive property. So every term in here has to be multiplied by this monomial, by this negative 6y squared. Notice that there are three terms in here. So remember, terms are separated by this addition and subtraction. So I have three terms. So this term is a negative 8y cubed. This term is a positive 3y. And this term is a negative 1/3. So I have three terms. So all of these terms have to be multiplied by negative 6y squared. Okay? And so when I do that, I get negative 6y squared. Now, since I have a bunch of negatives in here, I'm going to put those in parentheses. So this monomial has to be multiplied by this first term, just like this, plus this monomial has to be multiplied by that second term, negative 6y squared times 3y, plus, and then this monomial has to be multiplied by this third term, so negative 6y squared times a negative 1/3. Okay, and now let's go ahead and multiply each of those. So I'm hoping you notice that these three products right here, these three products is what we just went over, multiplying monomials, right? So that's what that is. So rather than spending all that time just regrouping and all that, which in your mind that's what you're doing, so you're going to look at this and you're going to regroup. So you're going to multiply the coefficients together. Negative 6 times a negative 8 is a positive 48. Okay? Y squared times y cubed. So y squared times y cubed, when you multiply like bases, you add exponents. That's y to the 5th power. Okay, over here, so let's say plus a negative 3 times a, negative 6 times a positive 3 is a negative 18. Y squared times y to the first is y cubed. And then plus a negative 6 times a negative 1/3 is a positive 2. And then that's y squared right here. So we get 2y squared. Now rewriting this better, because you need to remember that saying add a negative is the same thing as subtracting. So I'm going to rewrite this as 48, y to the 5th, subtract 18y cubed plus 2y squared. And that's it. That is all you're doing. Okay? All right. Now, so let's look at number 3. I'm going to go ahead and use another sheet of paper for that one. All right, so let's suppose we had this one. So we have this polynomial, and remember this polynomial has three terms, 5x squared, 6x, and a negative 1. That's important to see that. You keep the sign with it. And that's being multiplied by this monomial. So since I have a polynomial being multiplied by a monomial, I'm going to use the distributive property. So every term in here has to be multiplied by negative 3x squared. So I'm going to have negative 3x squared times 5x squared. Okay, so this times this, plus, and then negative 3x squared times 6x, plus, and then negative, let me do this over, negative 3x squared times a negative 1. Okay, be careful, that's a negative 1. Okay, now I'm going to multiply these monomials together using our properties of exponents. So the coefficients first, negative 3 times 5 is a negative 15. X squared times x squared, when you multiply like bases, you add those exponents. 2 plus 2 is 4, so you get x to the 4th. Plus negative 3 times 6 is a negative 18. X squared times x to the 1st is x to the 3rd, right? 2 plus 1 is 3. Plus a negative 3 times a negative 1 is a positive 3, and then we get x squared. And so rewriting this better, I get negative 15x to the 4th plus the negative 18x squared means subtract 18x squared, cubed rather, and then plus 3x squared. And that's it. So that's number 3. Okay? All right, let's look at another one. All right, so number 4, we have this polynomial, and this polynomial has 3 terms in it. 2x cubed, negative x squared y squared, and a positive 8y cubed, right? So I'm multiplying this polynomial by this monomial. So every term in here has to be multiplied by this monomial. So we're using distributive property. So when you rewrite it, you're going to say 3x squared y times that first term, 2x cubed, plus 3x squared y times that second term, a negative x squared y squared, plus 3x squared y times the last term, which is 8y cubed. Okay? And then now you're going to use the properties of exponents and the commutative and associative properties to simplify each. Let's go ahead and group the coefficients together in our minds. So 3 times 2 is 6, right? Okay, now let's multiply the like bases. X squared times x cubed. When you multiply like bases, you add exponents. 2 plus 3 is 5. So get 6 x to the 5th. And then the only other variable left is y. There's no y here, so you just bring it down. So this product is this. All right? Plus 3. Now remember, if there's no coefficient there, so it should be a negative 1, right? So 3 times a negative 1 is a negative 3. Now let's deal with the variable x's. X squared times x squared. When you multiply like bases, you add exponents. 2 plus 2 is 4, so you get x to the 4th. Notice this time I have y's in both monomials. Y to the 1st, y to the 2nd. 2 plus 1 is 3, so you get y cubed. Okay, plus 3 times 8 is 24. X squared, I have an x squared here, but I don't have any x's here, right? So I'm just going to bring down the x squared. But I have y's in both monomials, so I'm going to use the product rule. Y to the 1st times y to the 3rd is y to the 4th. And just rewriting this in a better way, I have 6x to the 5th, y, plus a negative 3x to the 4th, y to the 3rd is minus 3x to the 4th, y to the 3rd, and then plus 24x squared, y to the 4th. And that's it. All right. So that is multiplying a polynomial by a monomial. Okay. So that's objective B. All right. Let's look at another type. Well, before we do that other type, let me just do one more with multiplying a polynomial by monomial. I want to do one where you see a fraction. So let's talk about that. I have these 3 terms 9y squared, negative 6y, positive 1 is being multiplied by this monomial, which is 1/3 y squared. All right, so just like we've been doing, every term that's inside this polynomial, inside this parentheses, will be multiplied by this monomial. So I have 1/3 y squared times 9y squared plus 1/3 y squared, so this times a negative 6y plus 1/3 y squared times a positive 1. So then we're going to use the associative and commutative properties, and we're going to use the properties of exponents to help us with this. 1/3 times 9, so we're going to multiply the coefficients together. 1/3 times 9 is 3, so that's 3. Y squared times y squared, when you multiply like bases using the product rule, you add exponents, right? 2 plus 2 is 4. So we get this product here is 3y to the 4th. For that one, 1/3 times a negative 6, 1/3 times a negative 6 is a negative 2. So plus a negative 2. Y squared times y to the 1st is y cubed. And then plus 1/3 times 1 is 1/3. And all you have is just y squared left. Now let's go ahead and rewrite this better. So we prefer, instead of you saying plus and negative, you just say subtract. So that becomes 3y to the 4th, subtract 2y cubed, plus 1/3 y squared. And that's it. So that's all you do. Okay? All right, so now in part C, we're going to go ahead now and multiply polynomials together. Okay, so now we're going to multiply two polynomials together. And just like we did with when we multiplied a polynomial by a monomial, we're going to use the distributive property. Okay, so let's look at this example. All right, in these examples, it's going to say multiply. Okay, so in number 1, let's suppose we had this. We'll start with a simple example, x plus 3 times x plus 5. Okay, all right, now if this were, and let me go ahead and cover up one little part here. If all you had was this, you would go ahead and multiply everything in here by 3, right? You would say 3 times this and 3 times this, correct? So that was where you were using a polynomial being multiplied by a monomial. Well, you can use that idea here. So what you can do is think of this this way. So you would let me go ahead and kind of cover some parts up. So you would take this first term multiplied by this polynomial, and then you would take the second term multiplied by the polynomial. And so basically what you have is this. So watch what I'm doing so you can do the same thing. You're going to underline each of these right here. So there are two terms in that first polynomial. So always look at the first polynomial. Your first step is to take each of those terms and multiply by that second polynomial. So you see how I underlined that second polynomial? All right, and do the same thing here. All right, so notice the first term times the second, and then plus the second term times the second. Okay, and so here's what you have. You have x times x plus 5 plus 3 times x plus 5. So that's your first step. So that's using the distributive property. The first distributive property. Then we're going to do it again. We use the distributive property again. So you're going to multiply each of those terms by x, and then multiply each of those terms by 3. So we get x times x plus x times 5. That's right here. And over here, we get 3 times x plus, and then 3 times 5. All right, now simplifying this, x times x is x squared. 5 times x is 5x, put the coefficient in front, plus 3x, and then 3 times 5 is 15, right? And then combining like terms, always combine like terms. So 5x plus 3x is 8x. I get x squared plus 8x plus 15. And always put in descending order. When you have one variable, put in descending order. Okay, so that's using distributive property. Okay, so let's look at another one. Number 2, let's say we had 2x minus 5 times 3x plus 2. Okay, so I'm going to take each. Look at the first polynomial. In that first polynomial, you have two terms, 1, 2, And then each of those terms, you're going to multiply by that second polynomial. See, I'm underlining it. So first times that second polynomial, and then that second term times that second polynomial. Okay, now notice this time, remember how to determine your terms. This term here, that's a negative 5. So what's going to happen? So you're going to say 2x times that second polynomial, 2x times 3x plus 2, so using distributive property, and then minus, and then 5 times this, minus 5 times 3x plus 2. Okay? All right, now we're going to do the distributive property again. So you're going to say each of these terms times 2x, and each of these terms times a negative 5. Okay? Negative 5. So here's what we get. We get 2x times 3x, right? Plus 2x times this 2 plus a negative 5 times 3x, right? Plus a negative 5 times 2. So look, let's do it again. 2x times 3x, that's this. 2x times 2, that's this. A negative 5 times 3x, that's this. And a negative 5 times 2, that's this. Now we're going to simplify each of those products. And so 2x times 3x, 2 times 3 is 6. X times x is x squared. Plus 2 times 2 is 4. And then we have that x here, so 2x times 2 is 4x. Over here, I have a negative 5 times 3 is a negative 15. So a negative 5 times 3x is a negative 15x. And then plus a negative 5 times 2 is a negative 10. Rewriting this better, because remember, plus and minus, it helps if you write it as a subtraction. So you get 6x squared plus 4x minus 15x minus 10. Okay? Now let's combine like terms. 4x and a negative 15x, those are like terms, because remember, like terms, they have to have the same variable raised to the same exponent. See, this exponent's 2. These right here both have exponents 1. A positive 4 and a negative 15 is a negative 11. So I can rewrite this as 6x squared minus 11x minus 10. All right? So that's what we get there. Okay, now, remember, that's using distributive property. So let's look at this one. Suppose we had this. So this is number 3. Suppose in number 3 we had, let's say we had this problem. Okay, so in this one we have a polynomial being multiplied by a polynomial, just like the previous two, except in this one you have 3 terms. In the previous two, you had 2 terms, and then 2 terms, right? Okay, so this is 3 terms, this is 2 terms. We're going to do the same thing. So notice, I have 2 terms here, and I'm going to multiply each of those terms by this polynomial. So always think about it like that. So this term times that polynomial, and this term times that polynomial. Okay? So when I rewrite, I'm going to say y times this, y times that second polynomial, just like this, 2y squared plus y minus 6, and then minus 3 times that second polynomial, 2y squared plus y minus 6. Okay? And then I'm going to use the distributive property. So every term that's inside this polynomial is going to be multiplied by y, and then every term that's inside this polynomial will be multiplied by negative 3. Okay? So notice, each term multiplied by that second polynomial. See, this listed twice. This right here is listed twice. So it's been multiplied by the y and by the negative 3. All right? And so what we're going to do now is we're going to use the distributive property. So I get y times 2y squared. Now at some point you won't be able, you won't need to write this step right here, but I'm going to write it just to let you know in your mind this is what you're thinking of, this is what you should be thinking of. So you're going to say y times 2y squared, just like that, plus, and then y times y, okay, this times this, plus, and then y times a negative 6. And then next do the next one. Plus, I'm running out of room, negative 3 times 2y squared, plus the negative 3 times y, and then plus, I'm going to have to write it right here, negative 3 times a negative 6. Okay? So notice, y times 2y squared is this, y times y is this, plus, and then y times negative 6 is this, plus, A negative 3 times 2y squared is this. A negative 3 times y is this. And then a negative 3 times negative 6 is this. Okay? So let's simplify each of these products. All right? Y times 2y squared. Y times y squared is y cubed, so that's going to be 2y cubed. Plus y times y is y squared. Plus y times a negative 6 is a negative 6y, right? Plus negative 3 times 2y squared, and negative 3 times 2 is a negative 6y squared. A negative 3 times y is a negative 3y. And then plus negative 3 times a negative 6 is a positive 18. All right, so let's kind of rewrite where we see plus and negative, let's rewrite it as subtraction. So I'm going to rewrite this as 2y cubed plus y squared minus 6y minus 6y squared minus 3y and then plus 18. All right, so that's where I'm at. Okay, now let's combine like terms. So I have a y cubed here. There are no other y cubes, so I'm just going to rewrite it, 2y cubed. I have a y squared, and I see another y squared, right? So 1y squared and a negative 6y squared will give you a negative 5y squared. 1 and negative 6 is negative 5. So minus 5y squared. Now the y's. A negative 6y and a negative 3y. Combining like terms. Combining like terms. Negative 6 and a negative 3 is a negative 9. So you get negative 9y. And then finally all you have left is a constant, so plus 18, and there's your answer. Okay? Not difficult at all. So that's where you have, in this case we have three terms, a polynomial with three terms being multiplied by a polynomial with two terms. All right? So let's look at another one. So let's do, we may need another sheet of paper. So let me do this on another sheet. So this will be number 4. Number 4. So let's look at number 4. So in number 4, let's suppose we had this problem. So we have 3y plus 5. So we have this polynomial which contains two terms and is being multiplied by this polynomial which contains three terms. So I'm going to take each of these terms here, I'm going to multiply by this polynomial. So 3y times this, and then 5 times this. Okay? So I get 3y. Now remember, I'm using distributive property. So 3y times this. So 3y times 2y squared minus 6y plus 2, and then plus 5 times 2y squared minus 6y plus 2. Okay? So this times this plus this times this. All right? So you have this polynomial with three terms being multiplied by a polynomial with two terms. So that's the way we're going to do this. Then we're going to use the distributive property again to get rid of these parentheses. So each of these terms in here has to be multiplied by 3y. And the same thing here. That has to be multiplied by 5 in this case. So at some point, you're not going to have to rewrite this. You can look at this and then in your mind know exactly what to write down, what the answer is for that step. But for right now, I'm just going to go ahead and rewrite it. So I get 3y times 2y squared plus 3y times a negative 6y. That's the term, not 6y, but a negative 6y. Plus, and then 3y times 2. So this times this is this. 3y times a negative 6y is this product. And then 3y times 2 is this product. Now let's do this one. Plus 5 times 2y squared plus 5 times a negative 6y, and then plus 5 times 2. I ran out of room, so I had to put it right here. Okay, now let's multiply all of these products together. 3 times 2 is 6. Y times y squared is y cubed, right? That's a 6. Over here, 3 times a negative 6 is a negative 18. So I'm going to go ahead and just put negative 18 right now. Y times y is y squared. So I got negative 18y squared. 3 times 2 is 6. I got plus 6y, right? Over here, 5 times 2 is 10, so that's a y. 10, and then y squared. 5 times a negative 6 is a negative 30y. So 5 times a negative 6y is a negative 30y. And then 5 times 2 is 10, so plus 10. All right, now combining like terms, Let's see, I don't see any other y cubes. I'm going to write it first. Let's put in descending order. I have two terms with y squareds in it. A negative 18 and a positive 10 is a negative 8. So I get negative 8y squared. The y's, a positive 6 and a negative 30y, a positive 6y and a negative 30y is a negative 24y, and then plus 10. All right, and so that's the answer there. So it's not a difficult concept, right? It's fairly easy to do. You're just using the distributive property. Okay, now let's suppose we had this. We had 2x plus 3 squared. 2x plus 3 squared. Now you can use that same idea. You can use a distributive property. Now in the next lesson, you're going to look at some special cases. So you can look at the fact, well, if I'm squaring a binomial, is there another way I can think about this product? If I am multiplying, I'm going to show you real quick. If I'm multiplying two binomials together, is there another way I can think about this rather than just using the distributive property like I'm doing? And when you have two binomials, there is. So you may remember the FOIL method, first, outer, inner, last. And so we're going to talk about that in the next lesson. But in this lesson, all I wanted to do was to talk about multiplying polynomials by using that distributive property in that sense. So when you have a binomial squared like this, the best way to do that is to write out what this says. So this says 2x plus 3 times itself, right? 2x plus 3 times itself. And then you do what we did earlier. So you're going to take each of these terms and you're going to multiply it by the second polynomial. So 2x times this, and then 3 times this. And so you get 2x times 2x plus 3 plus 3 times 2x plus 3. And then get rid of the parentheses, use the distributive property. You get 2x times 2x, right? And you can skip that step. Most of you, if not all of you, can indicate that 2x times 2x is 4x squared. But let's just go ahead and write in that step right here. And then plus 2x times 3, just like that. So this times this is this, and 2x times 3 is this, and then now we're going to do this one. So distributed 3 here, we get plus 3 times 2x plus 3 times 3. Okay? And then let's go ahead and multiply all these monomials together. So 2 times 2 is 4. X times x is x squared. 2 times 3 is 6. So 2x times 3 is 6x, so plus 6x. And then 3 times 2x is 6x again. And then 3 times 3 is 9. What you're going to notice in the next lesson when we talk about that special product right here, notice that the outer and that you see these two terms, and we're going to talk about the outer and inner at some point, but you see those two terms, they're exactly alike. 6x plus 6x. So whenever you square a binomial and use distributive property, those two terms here will be exactly the same. And so in the next lesson, you're going to see how to write this formula that we're going to look at. So we get 4x squared, 6x plus 6x is 12x, and then plus 9. And that's it. All right, let's do one more, but this time we're going to use a negative sign, a subtraction sign. We're going to do one more with a binomial squared. So number 6, let's suppose you had 2x minus 3y squared. 2x minus 3y squared instead. Same thing, right? So let's write out what it means. What this means is 2x minus 3y times itself. That's what that means. And so now I'm going to multiply this polynomial by this polynomial, and the way I'm going to do that is to use the distributive property. So each of these terms in here, I'm going to multiply by that polynomial. So 2x times this, and a negative 3y times this. So I get 2x times this polynomial, 2x minus 3y, minus 3y times this polynomial, 2x minus 3y. Okay. Now the next step is to use the distributive property to get rid of those parentheses, just like this. And so let's write out what we have. We have this. We have 2x, this times 2x, right? 2x times 2x, plus 2x times a negative 3y. 2x times a negative 3y. Now let's take care of this one. A negative 3y times 2x, and then a negative 3y times a negative 3y, right? Okay, so notice 2x times 2x is this. 2x times a negative 3y is this, and then a negative 3y times 2x is this product, and then negative 3y times negative 3y is this product. So let's go ahead and multiply each of those monomials together. 2 times 2 is 4. X times x is x squared. Over here, 2 times a negative 3 is a negative 6. X times y is xy. Over here, negative 3 times 2 is a negative 6. Y times x is xy. And let's put it in alphabetical order. And then over here, a negative 3 times a negative 3 is a positive 9. Y times y is y squared. And remember a while ago what we mentioned, whenever you square a binomial, notice that these two terms are exactly the same. And that's going to be important in the next lesson. So when I combine like terms, I get 4x squared. A negative, now these are like terms because they both contain x, they both contain y, and the x's have the same exponent and the y's have the same exponent. A negative 6 and a negative 6 is a negative 12. So it becomes negative 12xy, that's a y, and then plus 9y squared. All right? And so that is the end of that lesson. And in the next lesson, we're going to look at those special cases, some special ideas around some of these products. And so that is the lesson on multiplying polynomials.